In this example, they let us know that the tangent line to this curve at the given point is given by the equation 4x plus y equals 0. We're going to use this information to find the value of the limit as x approaches -1 of this rational expression without using one of our processes for evaluating limits. So we know that this equation is our tangent line, and that is y equals -4x. So that means the slope of my tangent line equals -4 at x equals -1. So what does that mean? Remember that the slope of our tangent line is f of x minus f of our function evaluated at our point of interest over x minus our point of interest. So for this equation, the slope of our tangent line, f of x is x minus 1 squared, subtracting f of -1, which we know already is 4, all over x plus 1 from these double negatives canceling out. And we know that the slope of our tangent line is -4. So how can, and this should have been the limit as x approaches -1, right? Not a secant line, but a tangent line, which means it's the instantaneous rate of change at that point. So now over here, how can I manipulate this to look like this limit, slope of my tangent line? So I already see the denominator is what we need. So how can I manipulate my numerator? What I can try is to change this quadratic in standard form to look like this in vertex form, and hopefully they are the same. So in order to change it to vertex form, I need to complete the square. So in order to complete the square, I'm adding b over 2 squared. -2 over 2 is -1 squared, which is 1. And then I'll go ahead and subtract that 1 right there so that my equation doesn't change. Let me know if you need help with completing the square. So now this becomes the limit as x approaches -1. This factors to be x minus 1 squared, subtracting 4 when I combine like terms, all over x plus 1. Well, these are equivalent statements, so therefore this limit is -4. So that's a pretty cool application and connection.